Well, thank you very much, and it's great to be here. I'm Dan Britt. I run the Center for Lunar and Asteroid Surface Science and also the Exolith lab at UCF. My goal is exploration, lunar, Martian, asteroid exploration. And as a result of having this NASA-funded institute, the Center for Lunar and Asteroid Surface Science, I have a huge range of collaborators, ranging from NASA centers to universities to observatories all across the world. NASA is my primary funding agency. I get a little bit of money from NSF, but the overall approach is to support the exploration of these bodies. And the idea is to bring the best science to the assistance of commercial space ventures to develop local space resources, develop a bunch of partnerships with this so-called NewSpace Industry to develop innovative approaches to using space resources, and also train a new generation of exploration scientists and engineers. And I think we've been actually very successful in doing that. Impact, again, our point is to reduce the costs and the risks of exploration. Make UCF an international hub for simulants, development of hardware, partnerships with industry, testing of hardware. And also make UCF a go-to place for the engineering and science talent that is needed to staff this new space industry. And the good part about that is that they've already been hiring away our talent from my labs. My last postdoc got hired away after working with me for 5 months. So what is CLASS? That's a NASA-funded institute for a 5-year period of performance. This is the second renewal. And if you quote the requirements, it's to address basic and applied scientific questions fundamental to exploration. This is part of the NASA Solar System Exploration Virtual Institute. There's 9 of these. So I'm quite honored to lead one of them. And the whole process is to essentially, it's a block grant designed to attack exploration issues in a flexible fashion with the best scientific talent in the world. Access to that talent enables smarter, safer, and cheaper exploration. And so CLASS is a team that includes a lot of UCF scientists and engineers, but also people from 4 NASA centers, 16 universities. That spreads us over 4 continents and 18 time zones. We also partner with 15 new space companies and 5 observatories and research centers, including Arecibo. We support and sponsor the Exolith lab, which is something to address the exploration community's research and testing needs with realistic simulant materials for asteroid, lunar, Martian regoliths. We're the leading supplier of scientific simulants. And we have 1,200 customers worldwide, 45 countries. Last year, we delivered 40 tons of simulant. And also, we provide consulting to the users. So, because the people that are quite often using this material are not really quite sure the environment and the application that they really need. And so we provide an important consulting service to the scientific and engineering community. My own research is in regolith physical properties. The idea that if you know the detailed physical properties of regolith materials, you can understand and better design your hardware, your mission operations, your exploration technology. And so I've been working on density and porosity, thermal properties, dehydration behavior. I work with Dept on some of that for instance, here. Strength and cohesion, magnetic properties, electrostatic properties, angle of repose. So there are a lot of publications along those lines. And the nice thing is that what we do is we link the our analysis of the actual extraterrestrial materials when we can get a hold of them with the simulants. So you can see how well they simulate the physical properties of the material. I'm involved in several NASA missions, a total of 4. So earlier in my career, I was on Mars Pathfinder and Deep Space One. Now I'm actively in New Horizons and the Lucy mission. New Horizons is exploring the Kuiper Belt. Lucy was launched back in October and is heading sooner or later to the Trojan asteroids near Jupiter. This is a kind of long mission. So the nominal mission time is another 11 years after launch. So kind of job security. Another focus of class is in situ resource utilization. Why do we utilize local resources? Well, the problem is getting anything into Earth orbit requires a gear ratio, 200 times the mass of whatever your payload is in terms of rocket and fuel and other things. The way around this 200 to 1 gear ratio is to get as much of your materials as possible. Air, water, propellant, shielding, building materials, get that locally. A lot of technology needs to be developed in order to do that, because literally you're squeezing air out of rocks. But remember that rocks by mass are typically 45% oxygen. So the resource is there, it's just getting it out of that material. So class is experimenting with several molten regolith electrolysis processes for extracting metal and oxygen. We're also looking at various kinds of regolith processing, size sorting, beneficiation, uses of shielding. We're also developing cryogenic versions of the simulants to simulate lunar permanently shadowed regions and also the materials on Trojan asteroids. One of our goals is to be very reactive to the commercial market and partner and provide the best scientific support to as many new space companies as possible. So we provide scientific expertise broadly to the new space community. We have projects going on with a couple of small companies, well, what used to be small companies. TransAstra is a small company. Honeybee Robotics was just acquired by Blue Origin, which shows what they think about the kinds of collaborators that UCF has been able to work with. And we collaborate with on a large range of projects and proposals. I'll talk about a few in a minute. But we have a long list of commercial partners, several of which prefer non-disclosures, so we're not on this list. But we get around. Our initiatives, what we're doing right now is we're building a 10 by 10 meter with 1 meter depth regolith bin for testing lunar hardware. And we're using Exolith high fidelity lunar regolith simulant. It'll be equipped with gravity offload to simulate lunar gravity, and it's aimed at the needs of NASA and the new space industry. I've already written 2 letters to people writing proposals that want to use this facility. We're also supporting a range of SBIR, STTR, tipping point, luster, and other ISRU-related proposals in partnership with new space companies. This includes an SBIR for cryogenic simulants, for instance. And the whole point about this simulant and testing and support and scientific work is it feeds into mission involvement, more commercial partnerships, more ways of working with the commercial industry, and more new space jobs for our graduates and our participants. So I think what we do is we create a virtuous feedback loop of more involvement, gets us more involvement and makes us more important to this this industry. And that's the whole point, is to make UCF critical to new space so that they come here for not only their testing, their simulants, but also their employees. And mostly I want to just thank all the people I work with, the whole class and Exolith team, and particularly all the great engineering undergraduates that I hire in Exolith, who do an outstanding job. Thanks, and I'll take any questions.